Something from deep space is traveling toward us at over 220,000 kilometers per hour. Something that doesn't belong to our cosmic neighborhood. Something that has been traveling through the interstellar darkness for possibly billions of years. And now, in 2025, that something is here. Its name is 3I/Atlas, and depending on who you ask, it's either the most exciting scientific discovery of the decade, or potentially something that should keep us up at night. Take a deep breath, get comfortable, because what you're about to hear is going to challenge everything you thought you knew about our place in the universe. On July 1st, 2025, a telescope in Chile detected something. It wasn't unusual. Telescopes detect things constantly, asteroids, comets, space debris, but this object was different. It was moving too fast, and its trajectory didn't make sense if it came from our solar system. The ATLAS system, Asteroid Terrestrial Impact Last Alert System, is basically a robotic guardian that scans the skies looking for threats. It was designed to find asteroids that might impact Earth and give us enough time to, well, do something about it. But on that July night, ATLAS found something it wasn't designed for. A visitor. The astronomers did the calculations once, then twice. Then they called colleagues at other observatories. "We need you to confirm this," they said, and everyone came to the same impossible conclusion. This object was coming from outside our solar system. At that moment, 3I/ATLAS was 675 million kilometers from the Sun. To put that in perspective, that's more than 4 times the distance between Earth and the Sun, and yet it was already glowing, already had a tail, already behaving like a comet. But here's the strange thing. Normal comets don't do that. Not at that distance. You see, comets are basically dirty snowballs from space. They're made of ice, dust, and rock, frozen in the absolute cold of outer space. And they stay frozen until they get close enough to the Sun for the heat to start melting that ice. That melting process creates the iconic tail we associate with comets, that beautiful glowing trail that seems to follow them across the night sky. But there's a problem. Most comets have to get much closer to the Sun before that happens. We're talking about inside Jupiter's orbit, which is about 480 million kilometers from the Sun. Jupiter sits at roughly 5 astronomical units from the Sun, if you want to get technical about it. 3I/Atlas was glowing at more than 6 astronomical units from the Sun. Scientists scratched their heads. Maybe it's because it comes from interstellar cold, some said. Maybe its ice is more volatile, more sensitive to heat. That's a reasonable explanation. Interstellar space is incredibly cold, much colder than even the outer reaches of our solar system. So maybe after billions of years in that extreme cold, even a small amount of solar heat would be enough to start the sublimation process. But others weren't so sure. What if it's not ice that's creating the glow, they asked. What if it's something else? That question hung in the air like smoke. Nobody wanted to be the first to say what everyone was thinking. Let's pause here and talk about why this matters. You see, in all of human history, we've only definitively detected 3 objects coming from outside our solar system. 3. The first was Oumuamua in 2017. Its name means scout or messenger from afar, arriving first in Hawaiian. And when it showed up, it broke all the rules. It was cigar-shaped, tumbling wildly, and it was accelerating in ways that normal comets don't accelerate. To this day, scientists debate what Oumuamua really was. Some say it was a weird comet. Others suggest it was a fragment of a Pluto-like planet. And then there's Avi Loeb, who, well, we'll get to him in a moment. The second interstellar object was 2I/Borisov in 2019. This one was less controversial. It behaved exactly like a comet, it had a beautiful tail, it outgassed predictably, and it basically did all the comet things you'd expect. Scientists were relieved. Look, they said, interstellar objects can be normal. Oumuamua was just an anomaly. And then came 3I/ATLAS. The first few weeks after discovery were crazy. Every major telescope on Earth wanted a look. The Hubble Space Telescope rearranged its schedule. The James Webb Space Telescope, the most advanced piece of technology humanity has ever put into orbit, pointed its golden mirrors at this tiny speck of light. And what they found was puzzling. On July 21, 2025, Hubble captured an image that quickly circulated among the astronomy community. It showed 3I/A as a fuzzy ball of light with a teardrop-shaped tail streaming from it. The background stars were streaked because Hubble was tracking the comet as it moved, but the comet itself was sharp and clear. Except, it wasn't that clear. The dust coma, that fuzzy cloud around the nucleus, extended for thousands of kilometers. That's normal for a comet. But what wasn't normal was how bright it was for being so far from the sun. And what definitely wasn't normal was what the James Webb Space Telescope discovered when it analyzed its chemical composition. You see, Webb doesn't just take pretty pictures, it can split light into its component wavelengths and tell us exactly what an object is made of. It's like taking chemical fingerprints from space. And 3I/Atlas's fingerprints were weird. On August 6, 2025, the Webb team released their findings. 3I/Atlas has a carbon dioxide ice-to-water ice ratio of 8:1. Let me repeat that. 8 parts CO2 for every 1 part water. That's almost unheard of. Comets in our solar system are mostly water with a little CO2 mixed in. It's like making a smoothie, mostly water with some other ingredients for flavor. But 3I/Atlas is backwards. It's mostly CO2 with a little water. Well, maybe that's just how comets are where it comes from, you'd say. And you'd be right to think that. That's exactly the point. This comet is giving us a window into a completely different solar system, a place where conditions were so different from ours that comets formed with radically different compositions. But here's the unsettling question: what kind of solar system creates comets like that? Some scientists suggest 3I/Atlas comes from a low metallicity system. In astronomy, metal means anything heavier than helium, so we're talking about a system with very little carbon, oxygen, nitrogen, all the stuff we're made of. Maybe an ancient system formed when the universe was young, and these elements were rare. Others think it might come from a system where stellar radiation was particularly intense, boiling away everything except the most volatile compounds like CO2. But there's a third group of scientists who don't say much publicly but whisper at conferences after a few drinks. What if the composition isn't natural? What if it was designed? Now, before you think I've gone off the conspiracy deep end, let me be clear, the vast majority of scientists are completely confident that 3I/Atlas is a natural comet. NASA said so explicitly. Tom Statler, NASA's lead scientist for solar system small bodies, was quoted saying, "It looks like a comet, it does comet things, it very, very strongly resembles, in just about every way, the comets that we know. But, and here's that, but that makes this topic so fascinating." Tom Statler also added something else. He said, "It has some interesting properties that are a little bit different from our solar system comets." A little bit different. That phrase has been bothering some researchers ever since it was spoken, because when a NASA scientist says something is a little bit different, especially about an interstellar object, what does that really mean? Different how? Different enough to require explanations we haven't considered. Let's talk numbers for a second, because numbers are where things get truly strange. Initially, when 3I/Atlas was first discovered, astronomers estimated its size at about 20 kilometers in diameter based on its brightness. That's pretty straightforward logic. Brighter generally means bigger, as long as you know the object's albedo, how reflective it is. But then the new Vera C. Rubin Observatory in Chile got a look with its incredibly precise instruments, and they revised that estimate downward to about 10 kilometers. Then Hubble did its analysis, down again, 5.6 kilometers at most, possibly as small as 440 meters. Wait, what? How did we go from 20 kilometers to potentially less than half a kilometer? Here's the problem. All these estimates depend on how much of the brightness is coming from the solid nucleus versus how much is coming from the coma of dust and gas around it. And with 3I/Atlas, that distinction is blurry, very blurry. The coma is enormous. It extends hundreds of thousands of kilometers into space. Observations from the Cepheid Observatory between August 8 and 12, 2025, detected the CO2 gas plume extending at least 348,000 kilometers from the nucleus. To put that in perspective, that's almost the distance from Earth to the Moon. So here's a tiny object, possibly less than a kilometer wide, creating a cloud of gas that could envelop the entire Earth-Moon system. How is that even possible? A team from Auburn University studied 3I/ATLAS's water release using the Swift Space Telescope. What they found was remarkable. The comet is releasing water at a rate that suggests about 20% of its surface is actively producing water vapor. 20%. Normal solar system comets? They typically have about 3 to 5% of their surface actively outgassing, so 3I/ATLAS is 4 times more active than it should be. Well, the scientists said, maybe this is its first time visiting a star. Maybe it's been in the deep freeze of interstellar space for billions of years, and now that it's warming up, all that pristine ice is sublimating at once. That makes sense. It really does. It's the most logical explanation. But then someone pointed out something odd. If 3I/ATLAS is outgassing that vigorously, if it's losing 150 kilograms of material per second, which is what observations suggest, then it should be slowing down, or speeding up, or changing direction, even slightly. When comets outgas, they create a kind of natural rocket effect. The gas jets out from one side, pushing the comet in the opposite direction. We've seen this with countless comets. It's called non-gravitational acceleration, and it's completely normal. But here's where 3I/ATLAS gets weird again. In September 2025, a team led by scientists at Harvard analyzed 227 separate observations of 3I/ATLAS from observatories all around the world, spanning from May 15th to September 23rd. They were looking for any sign of non-gravitational acceleration, and they found almost nothing. The non-gravitational acceleration was below 15 meters per day squared. That's incredibly small. Almost imperceptibly small. Way smaller than it should be given how much gas the comet is releasing. Now, this led to 2 possibilities. Either the outgassing is somehow perfectly balanced on all sides, which would be an extraordinary coincidence, or the object is much, much more massive than we think. And that's where things got really interesting. Because if 3I/ATLAS is massive enough to not be affected by its own outgassing, if it's heavy enough to just shrug off 150 kilograms per second of material loss, then we need to completely revise our understanding of how big this thing is. Harvard astrophysicist Avi Loeb, and yes, here he is, right on schedule, did the math. He calculated that for 3I/ATLAS to show such little non-gravitational acceleration, despite its vigorous outgassing, it would need to weigh at least 33 billion tons. 33 billion tons. That would make its nucleus at least 5 kilometers in diameter, possibly larger, and that would make it thousands of times more massive than the other 2 interstellar objects we've detected. Now, Avi Loeb is, how do I put this delicately? He's controversial, very controversial. He was the chair of Harvard's astronomy department for nearly a decade. He's written hundreds of scientific papers. He's advised the President's Council on Science and Technology. By all accounts, he's a brilliant astrophysicist. But he's also the guy who suggested Oumuamua might be an alien spacecraft. Or at least, he's the guy who refuses to rule it out. And that's made him something of a pariah in certain scientific circles. When 3I/ATLAS was discovered, many astronomers privately wondered how long until Loeb suggests it's aliens. It didn't take long. On July 3, 2025, the Daily Mail interviewed him. The headline practically wrote itself. But to be fair to Loeb, he didn't say 3I/ATLAS was definitely alien technology. He said it could be. He said we should consider all possibilities. He said that dismissing the technological hypothesis without investigation would be unscientific. And then, on July 16, 2025, he co-authored a paper with 2 members of the Initiative for Interstellar Studies, a UK non-profit. The paper was titled, Is the interstellar object 3I/Atlas alien technology? The paper is, well, it's something. It's presented as largely a pedagogical exercise, which is academic speak for we're exploring this idea even though we don't necessarily believe it. But the paper takes the hypothesis seriously, very seriously. Let me read you some of the key points they make, because they're genuinely thought-provoking, even if they're probably wrong. First, they point out that 3I/ATLS's trajectory is suspiciously convenient. It passes remarkably close to Venus, Mars, and Jupiter during its journey through our solar system. How close? Well, it came within about 30 million kilometers of Mars on October 3, 2025. It will pass Venus at a similar distance, and it will approach Jupiter in March 2026 before leaving our solar system entirely. The paper calculates that the probability of a random interstellar object passing this close to 3 major planets is less than 0.005%, less than 5 in 100,000. That's weird, the paper suggests. That's really weird, almost like it was planned. Now, before you dismiss this, consider if you were an alien civilization sending a probe to study a star system, wouldn't you want it to pass close to the major planets? Wouldn't you design the trajectory to maximize the scientific return? But here's the thing, space is really good at creating coincidences. When you're dealing with billions of stars and trillions of possible trajectories, unlikely things happen all the time. That's just statistics. Still, it makes you think. Second, the paper points out that 3I/ATLS's orbital plane is tilted only 4.89 degrees relative to the ecliptic. That's the plane in which most planets orbit the Sun. Again, that's unusual. The ecliptic plane represents a tiny slice of three-dimensional space. The fact that 3I/ATLS came in at such a low inclination is, statistically speaking, quite rare. Loeb argues that this low inclination gives the object access to our planet with relative impunity. It's traveling in roughly the same plane as Earth, which would make it easier for the object to approach or even intercept our planet if it wanted to. But again, counterpoint, if you're an alien civilization with technology advanced enough for interstellar travel, why would you care about orbital mechanics? You could presumably approach from any direction. The fact that it's in the ecliptic plane might actually argue against it being a spacecraft, because it suggests it's bound by the same gravitational influences as natural objects. Unless, of course, that's exactly what an alien probe would want us to think. See, this is why this topic is so maddening. Every argument has a counter-argument. Every piece of evidence has an alternative explanation. Third, and this is where the paper gets really speculative, they note that 3I/ATLS reaches perihelion, its closest point to the Sun, on October 30, 2025. And during that perihelion passage, it will be completely obscured from Earth's view because it's on the opposite side of the Sun, from us. Convenient, the paper suggests. They propose that this would be the perfect moment for the object to perform what's called a reverse solar Oberth maneuver. This is a real concept from astrodynamics. An Oberth maneuver is when a spacecraft fires its engines at the point of maximum orbital speed, usually at periapsis, the closest point to the object it's orbiting, to maximize the change in kinetic energy. For an interstellar object traveling at enormous speeds, firing a thruster at perihelion while using the Sun's gravity could allow it to brake and become gravitationally bound to the Sun. In other words, instead of flying through and leaving forever, it could slow down enough to stay. And we wouldn't see it happen because the Sun would be in the way. The paper calculates that if 3I/Atlas performed such a maneuver, it could potentially reach Earth orbit by late November or early December 2025. That's next month, as of the time this video is being made in October. Now, let me be absolutely clear about something. The vast majority of astronomers think this is nonsense. Respectful nonsense, perhaps, but nonsense nonetheless. Jason Wright, an astronomer at Penn State who has actually worked on legitimate SETI research, wrote a detailed blog post dismantling Loeb's claims. He called the analysis very bad science. Wright points out something crucial that Loeb seems to have missed. The fuzz around 3I/ATLS isn't an artifact of image smearing or tracking errors. It's real. It's a genuine coma of dust and gas. And we know how to distinguish between genuine cometary features and tracking artifacts because, we've been doing this for over a century. When you track a moving object with a telescope, you adjust the telescope's motion to follow that object. The object stays centered and sharp, while the background stars streak across the image. This is basic astrophotography. Even undergraduate students know how to do this. The fact that 3I/ATLAS shows an extended coma in properly tracked images means it's outgassing. It means it's a comet, period. But Loeb's paper dismissed this evidence, suggesting the coma might be an observational artifact. That's not great scientific reasoning. There's another criticism too. If 3I/ATLAS were a spacecraft, if it was some kind of technological object, we'd expect to see certain signatures, artificial lights, radio emissions, regular geometric shapes, something that screams this was made by intelligence. We've seen none of that. Every observation from every telescope, from Hubble to Webb to ground-based observatories, shows an object that behaves exactly like a comet. It has a nucleus, it has a coma, it has a tail that points away from the sun, just like every comet ever observed. Tom Statler from NASA put it perfectly. It looks like a comet, it does comet things. And yet there's this nagging feeling that maybe, just maybe, we're missing something. Because 3I/ATLAS really is unusual in some ways. Its composition is genuinely weird. Its mass is genuinely larger than expected. Its trajectory is genuinely rare. Are those anomalies enough to suggest alien technology? Almost certainly not. But are they interesting enough to warrant continued observation and open-minded investigation? Absolutely. Let me tell you about something that happened in early August 2025 that didn't get as much attention as it should have. Loeb put out a public call to Elon Musk. He suggested that SpaceX, which launches rockets 3 times per week, could easily send a CubeSat mission to intercept 3I/ATLAS before it reaches perihelion. A CubeSat is a tiny satellite, usually about the size of a loaf of bread. They're cheap to build and can piggyback on other launches. The idea was to send one equipped with cameras and signal detectors to get close-up images of 3I/ATLAS and determine once and for all whether it's natural or artificial. The mission would have needed to launch by September or October 2025 to have any chance of catching up to the comet. As of now, mid-October, no such mission has launched. But here's what's interesting. Loeb framed his appeal in terms of risk management. He argued that even if there's only a 1% chance or a 0.1% chance, or even a 0.01% chance, that 3I/ATLAS is technological, the consequences of being wrong are so severe that we should investigate. It's Pascal's wager, but for alien spacecraft. If it's natural and we send a probe, we get unprecedented close-up data on an interstellar object. That's a win. If it's artificial and we don't send a probe, we've potentially missed the most important discovery in human history. That's a massive loss. So even with very low probabilities, Loeb argues, the expected value of investigation is high. It's actually a pretty compelling argument, philosophically speaking. Of course, it didn't happen. No mission was launched. And there are good reasons for that, beyond just we don't think it's aliens. First, launching a mission, even a CubeSat mission, in less than 3 months is incredibly difficult. Space agencies plan missions years in advance. There's design, testing, regulatory approval, launch window calculations. You can't just slap something together and hope it works. Second, the delta-V requirements. The amount of speed change needed to catch up to 3I/ATLAS are enormous. The comet is traveling at 221,000 kilometers per hour relative to the Sun. That's 61 kilometers per second. Catching up to something moving that fast would require chemical rockets with capabilities we simply don't have with small satellites. Third, and perhaps most importantly, the scientific community just doesn't think it's necessary. All the data we're collecting from telescopes is consistent with a natural comet. Sending a mission based on a hypothesis that most scientists consider unfounded would be a waste of resources. But still, wouldn't it be cool if we had? Let's talk about what actually happened when 3I/Atlas passed Mars on October 3, 2025. Multiple spacecraft at Mars tried to observe it. NASA's Perseverance rover pointed its navigation cameras at the predicted location. The European Space Agency's Mars Express and ExoMars Trace Gas Orbiter both attempted to image it. And they got something. The ExoMars Trace Gas Orbiter, using its CASIS camera, captured a series of images showing 3I/8LS as a fuzzy blob of light against the streaked background of stars. The comet was about 30 million kilometers from Mars at closest approach, which is actually pretty far, about 75 times the distance from Earth to our Moon. But here's what's interesting. The images show the same fuzzy extended glow that we've seen in every other observation. The coma extends to about 680 kilometers in the CASIS images, which is consistent with what we'd expect from a natural comet at that distance. Avi Loeb analyzed these images too. He pointed out that the coma we're seeing is only the brightest part, the core of the outgassing. The actual gas plume extends much, much farther, as we know from spectroscopic observations. He also noted that there hasn't been a significant increase in outgassing over the past few months, which is interesting. Most comets get dramatically more active as they approach the Sun. 3I/8LS seems to be maintaining a relatively steady level of activity. What does that mean? Honestly, we're not sure. It could be that the most volatile ice is sublimated early, and what's left is less reactive material, or it could be that the comet's rotation is presenting different faces to the Sun, and we're seeing an average of active and inactive regions. Or, if you're Avi Loeb, it could be that whatever's creating the glow isn't primarily driven by solar heating at all. Now we're approaching the most critical moment in this entire saga. Right now, as this video is being made, 3I/Atlas is heading toward perihelion. On October 30th, 2025, it will reach its closest point to the Sun, about 210 million kilometers, or 1.4 astronomical units. That's just inside Mars's orbit. It's close enough that the Sun's heat will be significantly stronger than what the comet has experienced so far on its inbound journey. And for several weeks around that date, we won't be able to see it from Earth, because it'll be on the far side of the Sun from our perspective. This is the moment that Loeb's paper suggested could be when something happens, when the object might perform a maneuver, when we might see evidence that it's not natural. Of course, the much more likely scenario is that absolutely nothing unusual will happen. The comet will swing around the Sun, outgas a bit more vigorously due to the increased heat, and then head back out toward the outer solar system on its way to interstellar space. But what if it doesn't? What if, when it emerges from behind the Sun in December, its trajectory has changed? Here's something that doesn't get talked about enough. We actually wouldn't immediately know if 3I/8LS changed course. When an object is behind the Sun from our perspective, we can't track it. We have to wait until it emerges, take new measurements of its position, and then calculate whether it's still on the trajectory we predicted. For a normal comet, this is straightforward. We know where it should be based on gravitational forces. If it's in a slightly different position, we can usually explain that with outgassing effects. But for an object that's supposedly not showing much non-gravitational acceleration despite vigorous outgassing, if its trajectory changed significantly while behind the Sun, that would be very hard to explain naturally. Not impossible. Space is full of surprises. Maybe it broke apart and the pieces are pushing each other around. Maybe it collided with something. Maybe there's some other natural explanation we haven't thought of. But it would be unusual, and it would require serious investigation. So, in a few weeks, when 3I/8LS emerges from behind the Sun, astronomers are going to be watching very carefully, not because they think it's aliens, but because science is about checking your assumptions, especially when dealing with objects as rare and strange as interstellar visitors. Let me address something that's probably on your mind. If 3I/8LS were really an alien probe, why would it matter? What's the actual concern? Loeb's paper invokes something called the dark forest hypothesis. This comes from a science fiction trilogy by Chinese author Liu Cixin. The idea is that the universe is like a dark forest at night, full of predators hiding in the shadows. Any civilization that reveals its presence risks being destroyed by others who view any potential rival as a threat. In this framework, the logical strategy for any advanced civilization is to stay hidden, actively search for other civilizations, destroy any you find before they can become a threat to you. It's a depressing view of the cosmos, but it's also a potential solution to the Fermi paradox. If the universe is full of life, why haven't we detected any of it? Maybe because everyone's staying quiet to avoid being noticed. In this scenario, an interstellar probe wouldn't be coming to say hello, it would be coming to assess threats and potentially eliminate them. Now, let me be very clear, this is extremely speculative science fiction thinking. There's zero evidence that the universe works this way. Most scientists who think about these questions believe that any civilization advanced enough for interstellar travel would be advanced enough to have moved beyond resource competition and violence. But Loeb argues that we can't know that for certain, and if there's even a small chance he's right, the consequences would be catastrophic. Here's my favorite part of this whole saga, and it reveals something important about how science actually works. Remember when I mentioned that Loeb created a Loeb scale for rating the probability that objects are technological? He currently gives 3I/ATLAS a 6 out of 10. But here's the thing, he's explicitly said he'll change that rating as new data comes in. He's not locked into his position. He's saying, based on what we know now, here's my assessment. Show me better data, and I'll revise it. That's actually good science. The problem is that most scientists think his current rating is way too high. They'd give 3I/ATLAS maybe a 0.5 or a 1 on that scale, acknowledging that we can never be 100% certain about anything, but expressing strong confidence that it's natural. The scientific community isn't divided on whether 3I/ATLAS is a comet. They're divided on whether it's worth publicly entertaining alternative hypotheses that they consider extremely unlikely. And that's an interesting philosophical question. At what point does keeping an open mind cross over into promoting ideas that mislead the public? Let's talk about what we actually know with high confidence. 3I/ATLAS is definitely from outside our solar system. Its trajectory is hyperbolic, meaning it's not gravitationally bound to the Sun. When we trace its path backward, it clearly originates from interstellar space, probably from the direction of the galactic center. It has traveled for an enormously long time to get here. At interstellar distances, even moving at 61 kilometers per second, it would take millions or even billions of years to travel between stars. This object is ancient. It might be older than our entire solar system. It is primarily made of carbon dioxide ice with some water ice mixed in. This is genuinely unusual compared to comets in our solar system, but it's not inexplicable. Different star systems have different compositions. This tells us something important about the chemistry of wherever 3I/ATLAS formed. It is outgassing actively, losing about 150 kilograms of material per second. This is creating a massive coma and tail, just like natural comets do. It poses absolutely zero threat to Earth. At its closest, it will be 270 million kilometers away, almost twice the distance from Earth to the Sun. It can't hit us. It won't affect our orbit or our climate or anything else. Those are the facts. Everything else is interpretation and speculation. Now, here's where things get philosophically interesting. We live in a universe with probably trillions of planets. The Kepler Space Telescope alone found evidence of thousands of exoplanets, and it only looked at a tiny slice of sky. We know rocky planets are common. We know water is common. We know organic molecules are common. So the ingredients for life appear to be everywhere. The question isn't really, is there other life in the universe? The answer to that is almost certainly yes. The question is there other intelligent technological life? And if so, why haven't we detected it? That's the Fermi paradox, and it's one of the most profound questions humans have ever asked. There are many proposed solutions. Life is common, but intelligence is rare. Intelligence is common, but technological civilizations destroy themselves quickly. Technological civilizations exist, but have no interest in contacting us. Technological civilizations are deliberately hiding. Technological civilizations are here, but we can't recognize them. Or, the most humbling possibility, we're actually alone, or at least so isolated in space and time that we might as well be alone. Every interstellar object that visits our solar system is a test of these hypotheses. If one of them turned out to be artificial, it would answer one of humanity's deepest questions: we are not alone. That's why Loeb is so insistent on investigating, not because he thinks he's definitely right, but because the potential payoff of being right is so enormous that even a tiny probability justifies investigation. Let me share something that I think gets lost in all the alien speculation. 3I/Atlas is scientifically valuable regardless of what it is. This is only the third confirmed interstellar object we've ever detected. Think about that. In all of human history, we've only seen 3 visitors from beyond our solar system. That's incredibly rare. Why so rare? Part of it is that interstellar space is mostly empty. Objects are tiny compared to the vast distances between stars. The chance of one wandering into our solar system is extremely low. But also, until very recently, we just weren't looking effectively. The telescope technology and survey programs we now have, like Atlas, like the Vera C. Rubin Observatory, are new. They're finding objects we would have missed just a decade ago. In fact, the Rubin Observatory is so good that in its first 10 hours of operation, it found 2,104 new asteroids. Previously, we were finding about 20,000 new asteroids per year. This one telescope could potentially find millions. What does that mean? It means we're going to find more interstellar objects, many more. 3I/ATA-LAS won't be the last visitor. It might not even be particularly unusual once we have a larger sample size. Here's something fascinating. Scientists are already planning for the next interstellar visitor. There's a mission called Comet Interceptor, scheduled to launch in 2029. The idea is brilliant. Instead of targeting a specific comet years in advance, they're going to park a spacecraft at a gravitationally stable point in space, specifically the Sun-Earth Lyell-2 point, and just wait. When a new long-period comet or interstellar object is detected heading our way, Comet Interceptor will have the flexibility to redirect and intercept it. It's like having a fast response team ready to investigate whatever the universe sends our way. This is important because with objects like 3I/Atlas, by the time we detect them and get telescopes pointed at them and analyze the data, they're already leaving. We miss the chance to see them up close. Comet Interceptor could change that. If another interstellar visitor comes through, we might actually be able to send a probe to fly past it, take high-resolution images, sample its gas and dust, and definitively determine what it is. Imagine if we'd had Comet Interceptor ready when Oumuamua came through in 2017. All the controversy and speculation could have been resolved with actual close-up data. There's something else worth mentioning. The public reaction to 3I/Atlas has been intense. When the news first broke in July, social media exploded, hashtags trended. Conspiracy theorists had a field day, and somewhere in between the serious scientific discussion and the wild speculation, something strange happened. People started genuinely wondering if this was it. If this was the moment humanity would finally definitively discover we're not alone. Reddit threads stretched into thousands of comments. Twitter, or X, or whatever we're calling it now, became a battleground between those who thought Loeb was a brave truth-teller and those who thought he was dangerously irresponsible for even suggesting the alien hypothesis. YouTube channels devoted to unexplained phenomena pumped out video after video with increasingly dramatic titles. TikTok was full of creators doing explainers that ranged from remarkably accurate to completely unhinged. And then something really interesting happened. People started prepping. I'm serious. There were reports, unverified but persistent, of people stockpiling food and water, not in massive quantities, not building bunkers, but quietly, discreetly adding extra supplies to their pantries, just in case. Loeb himself received emails, lots of emails. He published some of them in his blog posts with permission from the senders. They're haunting, honestly. One person wrote, "Dear Dr. Loeb, I made plans, a moderate amount of long shelf-life food, after reading your initial 3I/ATLAS posts. More recent information brings to mind something Han Solo said. I have a bad feeling about this. I have no illusions about our chances of survival if we are targeted for elimination as per the Dark Forest theory. However, I would like to spend time with my family in the lead-up to a potential encounter. Another wrote about how their father had passed away, and how Loeb's work on popularizing science had been one of the things that brought them together in those final years. The person thanked Loeb, said their father had always wished to meet him. These aren't crazy people. These are ordinary humans confronting the possibility, however remote, that something extraordinary might be happening, and they're responding with a very human mixture of fear, hope, and wonder. But here's where the story takes a darker turn. And this is something that genuinely concerns me. There were also conspiracy theories. Of course there were, because whenever something mysterious happens, especially something involving space or government agencies, the conspiracy theories multiply like bacteria in a petri dish. Some people claimed that 3I/ATLAS was a distraction. They're using this to distract us from the Epstein files, they said, or from political scandals, or from economic problems, or from whatever their particular concern happened to be. Loeb addressed this directly. He pointed out quite reasonably that you can't fake an object in space that's visible from multiple telescopes around the world, independently operated by different countries and institutions. 3I/ATLAS is real. You can see it yourself with a half-meter telescope if you know where to look. But conspiracy theories don't care about logic. They're self-sealing. Any evidence against them becomes evidence of a deeper conspiracy. Other theories were even stranger. Some claimed that governments had known about 3I/ATLAS for months or years, but had kept it secret. Why? Well, that depended on which conspiracy you believed. To prevent panic, to maintain control, to hide the fact that they'd already made contact with aliens. None of this is true, by the way. The discovery was made by a civilian telescope program and announced publicly within days. But truth and conspiracy theories have never been particularly close friends. There's something insidious about this whole situation that I think we need to talk about honestly. The way our media ecosystem works now, with social media algorithms prioritizing engagement over accuracy, means that sensational claims spread faster than careful scientific analysis. Always. When Loeb published his paper suggesting 3I/ATLAS might be alien technology, that got headlines. Big headlines. Harvard scientist says Comet could be alien spacecraft. That's clickable. That gets shares and retweets and views. When other scientists published careful rebuttals explaining why it's almost certainly just a comet, that got much less attention. Scientists confirm object is probably natural doesn't have quite the same ring to it. This creates a dangerous asymmetry. The spectacular claim reaches millions of people. The mundane reality reaches thousands. And so you end up with a large population that's vaguely aware that some scientist said that thing might be aliens without understanding the full context or the scientific consensus against that idea. Is that Loeb's fault? Partially, maybe. He knows how media works. He knows that when he publishes a paper with alien technology in the title, it's going to get coverage. He could have been more circumspect. He could have kept his speculation private until he had stronger evidence. But on the other hand, should scientists self-censor interesting ideas because they might be misunderstood by the public? That seems wrong too. Science is supposed to be about exploring possibilities, even unlikely ones. It's a genuine dilemma, and I don't think there's an easy answer. Let me tell you about what happened in early October that didn't make many headlines. The US government experienced a partial shutdown. Nothing major, just the usual political dysfunction that we've all become depressingly accustomed to. But one consequence was that NASA's communications slowed down significantly. And people noticed. Why is NASA suddenly quiet about 3I/ATLAS? They asked on social media. What are they hiding? The answer, of course, was nothing. They weren't hiding anything. They were just experiencing bureaucratic delays because some of their communications staff were furloughed during the shutdown. But in the absence of official information, speculation filled the void. NASA knows something. They're not telling us the truth. The silence is suspicious. Loeb himself had to address this. He pointed out, with what I imagine was considerable exasperation, that the media blackout people were worried about was just a combination of government shutdown and the normal pace of scientific research. Large research teams take days or weeks to analyze data and publish results. That's not sinister. That's just how science works. But the fact that he had to explain this at all shows how primed people are to see conspiracy and cover-up in perfectly ordinary delays. And then October 3rd came. The day 3I/ETIALAS passed closest to Mars. The anticipation was palpable. Would we get clear images? Would the spacecraft at Mars be able to see it? Would there be any surprises? The European Space Agency had Mars Express and ExoMars Trace gas orbiter both positioned to observe. NASA's Perseverance rover was taking shots in the sky. Even the Mars Reconnaissance Orbiter's high-rise camera, which can resolve features just a few feet across on the Martian surface, was trying to catch a glimpse. And then we waited. Because that's the thing about space exploration that people don't always appreciate. It's slow. The data has to be transmitted from Mars to Earth, which takes anywhere from 4 to 24 minutes depending on where the planets are in their orbits. Then it has to be processed, analyzed, turned into images that humans can interpret. Hours passed, then days. And the conspiracy theories spun up again. Why is it taking so long? What did they see that they're not telling us? When the images finally came out, they showed exactly what scientists expected. A fuzzy ball of light, a comet, doing comet things. The ExoMars Trace gas orbiter's CASIS camera captured it beautifully. There it was, a diffuse glow against the black of space, with the background stars streaked from the tracking motion of the camera. The glow extended about 680 kilometers in the images. The brightest part, presumably the nucleus and inner coma, was slightly extended toward the sun, just as you'd expect from outgassing pushing material away from the solar-facing side. It looked like every other comet humanity has ever photographed, just interstellar. Loeb analyzed the images too, of course. He noted that the surface brightness profile was consistent with earlier Hubble observations, accounting for the fact that 3I/ETIALAS was now closer to the Sun and therefore brighter. He observed that there hadn't been a major change in outgassing activity, and he maintained that this didn't rule out the technological hypothesis. Which, to be fair, it doesn't. You can't prove a negative. No observation can definitively rule out every possible form of alien technology. Maybe it's a probe covered in ice. Maybe the outgassing is intentional camouflage. Maybe. But at some point, you have to apply Occam's razor. The simplest explanation that fits all the facts is usually correct. And the simplest explanation is that it's a comet. Now we're getting close to the critical moment. As I'm writing this script, it's mid-October 2025. 3I/ETIALAS is approaching perihelion. In about 2 weeks, it will pass behind the Sun from Earth's perspective. And we won't see it again until December. 2 months of darkness. 2 months where we can't track it. 2 months where, if something unusual were to happen, we wouldn't know about it until after the fact. This is the moment that Loeb's paper highlighted as significant. The time when a hypothetical spacecraft could perform maneuvers hidden from our view. The time when the object could change course, slow down, establish itself in an orbit around the Sun. And here's the thing that makes this genuinely suspenseful. We won't know if that happened until December. If 3I/ETIALAS emerges from behind the Sun in exactly the position and trajectory we predict, case closed. It's a comet following the laws of physics. Mystery solved, sort of. But if it emerges somewhere else, if its velocity has changed, if its trajectory has altered in ways that can't be explained by outgassing, then we have a problem, or an opportunity, or quite possibly the most important discovery in human history. Let me paint you 2 scenarios, 2 possible futures that could emerge from this. Scenario 1. The normal universe. December rolls around. 3I/ETIALAS emerges from behind the Sun. Telescopes lock onto it immediately. Everyone's been waiting. Calendars marked, observing time scheduled. And it's exactly where it's supposed to be. Maybe a few thousand kilometers off due to outgassing effects, but within the expected parameters. It continues outward, passes Jupiter in March 2026 as predicted, and then, over the course of years and decades, it fades from our telescopes, becoming dimmer and dimmer until it's just another point of light among billions, indistinguishable from the stars. It leaves our solar system the same way it entered. Alone, ancient, silent. Scientists publish their papers. Interstellar Comet 3I/Atlas, Composition and Dynamics. They note the unusual CO2 to water ratio. They discuss what it tells us about planetary formation in low metallicity systems. They thank the observatories and funding agencies. Loeb publishes too, probably still maintaining that the data is consistent with either a natural or artificial origin, but acknowledging that the natural explanation is more parsimonious. The news cycle moves on. 3I/ATLAS becomes a footnote, something nerdy people bring up at parties. Remember that comet everyone thought might be aliens. Life continues. We wait for the next interstellar visitor, and this time we'll be better prepared with missions like Comet Interceptor. That's the most likely outcome. That's what's probably going to happen. But then there's Scenario 2, The Strange Universe. December. Telescopes swing toward the predicted position of 3I/ATLAS, and it's not there. Not exactly. It's close, but off. Significantly off. More than outgassing can explain. Someone runs the calculations. It's slowed down. The velocity is wrong. More observations, more calculations. The trajectory has changed. Not a lot, but enough. Enough that it's no longer on an escape trajectory from the solar system. It's in a highly elliptical orbit around the sun. The news breaks slowly at first. Scientists are cautious. They recheck everything. Could there have been an undetected collision? A breakup event? Some natural explanation? But the data keeps coming in, and it's all consistent with a powered deceleration at perihelion, a maneuver, a choice. Within days, the story goes global, and I mean truly global. This isn't just science news. This is the biggest news in human history. Governments convene emergency meetings. The UN Security Council holds closed-door sessions. Space agencies around the world try to coordinate observations. And everyone asks the same question. What do we do now? Because if 3I/ATLAS changed its trajectory deliberately, if it chose to stay in our solar system, then what's its next move? In this scenario, Loeb becomes simultaneously the most vindicated and the most terrified scientist on Earth. I told you, he says in interviews, but there's no satisfaction in his voice, because if he's right about this, he might also be right about the dark forest hypothesis. And that's absolutely terrifying. In this scenario, humanity's response would be chaotic. There's no playbook for this. We've never done this before. We have no protocols, no procedures, no established chains of command for what to do when an interstellar object reveals itself to be artificial. The SETI community has talked about this, of course. They've proposed frameworks for how to respond if we detect an alien signal, but those protocols were written assuming we'd detect a radio signal from light years away, something that gives us time to think, to plan, to debate. Not an object already inside our solar system, not something that's already here. Let me walk you through what would probably happen in those first hours and days, because I think it's important to understand just how unprepared we actually are for this. First, there would be confirmation and reconfirmation. Every observatory would be tasked with verifying the trajectory change. They'd check for instrument errors, calculation mistakes, any possible mundane explanation. Because the implications are so enormous that you need absolute certainty before making any announcements. But eventually, probably within 24 to 48 hours, enough data would accumulate that denial becomes impossible. The object changed course. It's no longer leaving, it's staying. That's when the calls start going out. NASA administrators to the President, ESA directors to the European Commission, Roscosmos to the Kremlin, space agencies to their respective governments. And here's where it gets interesting. What do those governments do? Do they tell the public immediately? Do they wait? Do they coordinate with other nations first? In today's world, with social media and amateur astronomers and leaked documents, you probably can't keep it secret for more than a few days anyway. Someone would notice. Someone would talk. The cat would escape the bag, whether officials wanted it to or not. So there would probably be a press conference, joint, if possible. NASA, ESA, maybe JAXA and other major space agencies together. And they would have to tell the world. We have detected an anomaly. The object we've been calling 3I/Atlas has altered its trajectory in a manner inconsistent with natural processes. We are investigating. They wouldn't say aliens. Not at first. They'd use careful technical language. Anomalous acceleration, non-gravitational trajectory change, possible artificial origin. But everyone would know what they meant. The global reaction would be, I honestly don't know how to predict it. It would probably depend a lot on how the news was presented and what additional information was available. If officials could say, we've detected trajectory changes, but the object is not approaching Earth and poses no immediate threat, that would help. People can handle uncertainty better when they don't feel immediately endangered. But if there was any indication that 3I/Atlas was maneuvering closer to Earth, if its new orbit brought it anywhere near our planet, panic. There would be panic. Stock markets would crash. Governments would activate emergency protocols. Religious leaders would be inundated with questions about theological implications. Social media would be completely overwhelmed. And in the midst of all this chaos, scientists would be working frantically to learn everything they could about the object. Every telescope would be pointed at 3I/Atlas. Every radio telescope would be listening for signals. Space agencies would be dusting off old mission proposals and seeing if anything could be launched quickly. Because now the question isn't, is it artificial? The question is, what does it want? This is where the dark forest hypothesis becomes genuinely chilling. See, in Liu Cixin's framework, there are really only a few reasons an advanced civilization would send a probe to another star system. 1. Scientific curiosity. They're explorers like us. They want to study other worlds, other forms of life. In this case, revealing themselves might be intentional. Hello, we're here, we come in peace. Let's exchange information. 2. Resource acquisition. They need something our solar system has. Maybe they're low on certain elements. Maybe they need water or organic compounds or something we haven't even thought of. They're not necessarily hostile, but they are pragmatic. They'll take what they need. 3. Threat elimination. They've detected our radio signals, our signs of technological civilization. They've calculated that we could, in 1,000 or 10,000 or 1,000,000 years, become a threat to them. So they're eliminating the threat now, while we're still primitive and vulnerable. In scenario 1, we might be okay. Scary, certainly. World-changing, absolutely. But potentially survivable and even beneficial. In scenario 2, we're in for negotiations we're not prepared for. What do you offer a civilization that can cross interstellar space? What could they possibly want from us that they couldn't get more easily elsewhere? In scenario 3, well, in scenario 3, we're already dead. We just don't know it yet. Loeb explored this possibility in his writings, and it's deeply unsettling. He pointed out that 3I/Atlas's timing is suspicious. It arrived just as humanity has reached a critical threshold. We're on the verge of becoming a multi-planetary species. SpaceX is planning Mars missions. China's developing its space program. Within a few decades, we might have self-sustaining colonies on other worlds. And once that happens, we become much harder to eliminate. You can't wipe out a multi-planetary species with a single strike. So if you're a galactic predator operating on the dark forest principle, now would be the time to act. While we're still confined to one fragile planet, while we're still vulnerable. The fact that 3I/Atlas could potentially reach Earth in late November or early December 2025, mere months after its discovery, means we'd have almost no time to prepare any kind of defense. Not that we could defend ourselves anyway. What are we going to do? Shoot missiles at something that crossed light years of space? That would be like a medieval knight trying to shoot down a stealth bomber with a crossbow. If 3I/Atlas is hostile, if it's here to eliminate us as a potential future threat, then we're helpless. Completely, utterly helpless. But here's the thing that Loeb and others have pointed out: this scenario, while terrifying, is also probably the least likely. Because if you're an advanced civilization capable of interstellar travel, you have energy resources that dwarf anything we can imagine. You can manipulate matter at levels we can barely conceive. You have technology that would look like magic to us. With that kind of power, why would you feel threatened by a species that only figured out how to split the atom 80 years ago? That would be like modern humanity feeling threatened by termites, because they might eventually evolve into something dangerous. It's not impossible, but it seems unlikely. More likely, if 3I/Atlas is artificial, it's a probe. A von Neumann probe, perhaps, a self-replicating machine sent out to explore the galaxy, catalog planets, maybe report back to its creators. Maybe those creators are long dead. Maybe they sent out thousands of these probes millions of years ago, and they're still out there, still exploring, still cataloging, long after the civilization that built them has turned to dust. Maybe 3I/Atlas has visited hundreds or thousands of star systems. Maybe ours is just another entry in its database. Star System 8,472,104,388. One yellow dwarf star. 8 planets. Third planet from star shows signs of technological civilization at primitive level. Status. Observed. Moving to next system. If that's the case, then 3I/Atlas might stay in our solar system for a while, gather data, and then leave. We'd never even know we were being catalogued. There's another possibility that's both hopeful and sad. Maybe 3I/Atlas is a message in a bottle. Imagine a civilization that knew they were dying. Maybe their star was going supernova. Maybe they exhausted their planet's resources. Maybe they destroyed themselves in war. But in their final days, they built probes. Not weapons, not colonies, just messages. We were here. We existed. We thought and felt and loved and created. Please, whoever finds this, know that we were real. And they sent those probes out to wander the galaxy forever, carrying the last testament of a dead civilization. If 3I/Atlas is something like that, if it's a memorial rather than a threat, then encountering it would be one of the most profound and melancholy moments in human history. We'd be receiving a message from the dead, from people who lived and died under alien stars, who we'll never meet, who wanted nothing more than to be remembered. There's something almost unbearably sad about that idea, and also something beautiful. Of course, all of this assumes we're in scenario 2, where 3I/Atlas actually does something unusual. We're probably not. We're probably in scenario 1, where it's just a comet and all this speculation will look silly in hindsight. But the fact that we're having these conversations at all, the fact that serious scientists are publishing papers about the possibility of alien technology, the fact that space agencies are paying attention, the fact that you're watching this video right now, all of that tells us something important. We're ready. Maybe not technologically ready, maybe not politically ready, but psychologically, we're ready to consider the possibility that we're not alone. That's new. That's a change that's happened gradually over the past few decades. 50 years ago, talking about aliens was fringe stuff. You kept it quiet if you were a serious scientist. You didn't risk your reputation on wild speculation. Now we have serious academic papers discussing the possibility. We have congressional hearings on UAPs, unidentified aerial phenomena, the new term for UFOs. We have NASA establishing official protocols for investigating anomalous objects. The conversation has shifted. We're taking it seriously. And that's good. Because eventually, maybe not with 3I/Atlas, maybe not in our lifetimes, but eventually, we're going to encounter something from beyond Earth. It might be a signal. It might be an artifact. It might be something we can't even imagine yet. And when that day comes, we'll need to be ready. Not just with telescopes and spacecraft, but with the right mindset, open-minded enough to recognize something truly alien when we see it, but skeptical enough to not jump to conclusions. Let me tell you what I think is actually going to happen with 3I/Atlas. In 2 weeks it will pass perihelion, it will swing around the sun, hidden from our view, and it will get hot, really hot. The solar radiation at that distance will be intense enough to vaporize more of its ices, create a bigger coma, maybe even cause the nucleus to crack or break apart. Then in December it will emerge, and telescopes around the world will immediately lock onto it, and it will be exactly where physics says it should be. Maybe a little bit off due to outgassing. Comets are never perfectly predictable because the jets of gas they emit push them around in complex ways, but within normal parameters, within the range of natural explanation. Scientists will study it intensely for the next few months as it heads outward. They'll measure its composition in more detail. They'll calculate its origin more precisely, maybe narrow down which region of the galaxy it came from, even if they can't identify a specific star system. They'll publish papers. They'll argue about interpretation. They'll add 3I/Atlas to the catalogue of known interstellar objects alongside Oumuamua and Borisov. And then, slowly, it will fade from view. By the time it passes Jupiter in March 2026, it will already be getting dimmer, the sun's warmth fading, the outgassing slowing down. A few more months, and it will be too faint for all but the largest telescopes to detect, and then it will be gone. Back into the dark between stars, traveling for billions more years until maybe, possibly, it enters another star system and someone else, something else, wonders what it is. But here's what won't go away: the questions. Even if, when, 3I/Atlas turns out to be natural, we'll still be left wondering. Because the universe has just demonstrated, yet again, that it can surprise us, that it can send us visitors from unimaginable distances, that we're not as isolated as we sometimes feel. There are comets out there right now wandering between the stars, fragments of worlds we'll never see, messengers from stellar nurseries that formed before our sun even existed. And occasionally one of them finds its way to us. 3I/Atlas is the third we've detected. It won't be the last. The Vera C. Rubin Observatory is going to revolutionize our ability to find these objects. Within a decade, we might detect dozens of interstellar visitors. Within a century, hundreds or thousands. And each one will be a treasure trove of information, a sample from another corner of the galaxy, delivered free of charge to our doorstep. Some of them will be weird. Some will challenge our understanding. Some might even be genuinely anomalous in ways that require new physics or new explanations to understand. And yes, eventually, one of them might actually be artificial. Not 3I/Atlas, probably. But someday we'll detect something that we can't explain away, something that's undeniably technological, something that forces us to confront the reality that we're not alone. When that day comes, and I genuinely believe it will come, whether in my lifetime or yours or our grandchildren's, everything will change. Not necessarily in the ways science fiction depicts. There probably won't be flying saucers landing on the White House lawn. There probably won't be Independence Day-style invasions or Star Trek-style diplomatic first contacts. It will probably be something stranger, something we didn't predict. Because real alien contact, when it happens, won't follow the scripts we've written for it. Maybe it'll be a signal that's clearly artificial but impossible to decode. A message we know is meant for someone, but we can't figure out what it says. Maybe it'll be an artifact that's obviously manufactured, but whose purpose we can't determine. Technology so far beyond ours that we can't even recognize it as technology. Maybe it'll be something biological, seeds or spores drifting between stars, and we'll discover that life doesn't just exist on other worlds, it travels between them. Or maybe it'll be something we haven't even imagined, something that challenges our basic assumptions about what life is, what intelligence is, what communication is. The universe is under no obligation to make sense to us. It doesn't care about our expectations or our science fiction stories or our philosophical frameworks. It just is. And occasionally it sends us reminders of how much we don't know. 3I/Atlas is one of those reminders. So what is 3I/Atlas doing to Earth? The direct physical answer is nothing. It's too far away to affect us gravitationally. It's not going to hit us. It's not going to change our orbit or our climate or anything else. But the indirect answer, the psychological, cultural, philosophical answer, it's making us think. It's making us wonder. It's forcing us to confront questions we usually prefer to ignore. Are we alone? What's out there? What if something is watching us? What if something is coming? These aren't comfortable questions. They challenge our sense of security, our sense of importance, our sense of control over our destiny. But they're important questions. Maybe the most important questions we can ask. Because the answer, whatever it turns out to be, will fundamentally reshape how we understand our place in the universe. If we're alone, truly alone, then we're the universe's only way of understanding itself. We're the only consciousness, the only intelligence, the only meaning makers in a cosmos of dead matter and empty space. That's a staggering responsibility and a crushing loneliness. But if we're not alone, if there are others out there, other minds looking up at their own night skies and wondering the same questions we wonder, then we're part of something larger. We're one voice in a cosmic conversation that spans galaxies and eons. We're not alone in the dark. Both possibilities are profound. Both are humbling. Both should inspire us to be better, to do better, to reach further. There's one more thing I want to talk about before we close this out, and it's about hope. Because for all the scary speculation, for all the dark forest hypotheses and invasion scenarios and existential threats, there's something fundamentally hopeful about our response to 3I/ATL. We looked up, we noticed it, we studied it, we argued about it, we wondered. That's what humans do. We're curious. Even when we're scared, even when we're uncertain, we want to know, we want to understand. And that curiosity, that desperate, beautiful need to figure things out, might be our greatest strength. If there are aliens out there, if some of them are hostile, if the dark forest is real, well, we can't do much about that. We're too primitive, too vulnerable, too young a species. But if there are friendly aliens out there, if some of them are curious too, if some of them are looking for other minds to talk to, then our curiosity is an invitation. It's a signal we're sending out into the cosmos. We're here, we're thinking, we want to know. Come talk to us. Every telescope we build is part of that signal. Every space probe we launch, every paper we publish, every video like this one that tries to explain the mysteries of the universe to anyone who's interested. We're saying we care about this, we think it matters, we're ready for whatever comes next. And maybe that's the real answer to what 3I/ATLS is doing to Earth. It's not doing anything to us physically, but it's doing something to us psychologically, culturally, spiritually. It's reminding us that we live in a vast, strange, ancient universe, that we're newcomers here, that there's so much we don't know, so much we're only beginning to understand. It's humbling us, and that's good. We could use some humility. For most of human history, we thought Earth was the center of everything. Then we learned we're just one planet, among many, orbiting an ordinary star in an ordinary galaxy. But even then, we could still imagine we were special. Maybe we were the only intelligence. Maybe we were the universe's way of understanding itself. Maybe we mattered in some cosmic sense. 3I/Atlas and Oumuamua before it, and whatever comes after it, reminds us that the universe is bigger than our comprehension, that things happen out there that have nothing to do with us, that we're not the center of the story. And somehow, that's liberating. Because if we're not the center, if we're not special, if we're just one species among potentially billions, then we don't have to carry the weight of cosmic significance. We can be curious, we can be explorers, we can reach out into the darkness and see what reaches back. So here we are, in late October 2025, watching a visitor from another star system swing around our sun. In a few weeks it will disappear behind that sun, and we won't see it for 2 months. And yes, there's a tiny infinitesimal chance that when it emerges, everything we know will change. But probably, almost certainly, it will just be a comet, an ice ball from another world, following the laws of physics, heading back out into the dark. And that's okay. That's more than okay, because even if it's just a comet, it's still magic. It traveled for millions or billions of years through the cold and the dark. It wandered between stars. It passed through clouds of gas and dust, through regions where new solar systems were forming, through the territories of civilizations we can only imagine. And then, by chance or fate or the simple mathematics of gravity, it found its way to us. For a brief moment, just a few months in the life of an object that's billions of years old, its path intersected with ours. We saw it. We studied it. We wondered about it. We argued about whether it was natural or artificial, whether it was a threat or an opportunity, whether it meant we were alone or part of something larger. And then we watched it leave, heading back out into the darkness, carrying with it no answers, only more questions. That's the story of 3I/ATLS, a mystery that appeared in our sky, burned bright in our telescopes and our imaginations, and then faded away, leaving us changed in ways we're still trying to understand. Whether it's a comet or a spacecraft, whether it's natural or artificial, whether it matters or doesn't, in the end, maybe those aren't even the right questions. Maybe the right question is, what does it mean that we're capable of asking these questions at all? What does it mean that we're a species that can look at a distant speck of light and wonder about alien civilizations? That we can build telescopes powerful enough to analyze the chemical composition of objects billions of miles away? That we can conceive of technologies so advanced they'd be indistinguishable from magic? That's the real miracle, not 3I/ATLS. We're a species of curious apes on a small planet who taught ourselves to read the stars, who figured out the laws that govern the universe, who built machines that can see across billions of miles and billions of years. And now we're watching a visitor from another star system, trying to figure out what it is, where it came from, what it means. That's extraordinary. That's worth celebrating, regardless of what 3I/ATLS turns out to be. In December, when 3I/Atlas emerges from behind the sun, we'll get our answer, or at least we'll get more data. If it's where it's supposed to be, the mystery will be solved, or at least reduced to more manageable questions about composition and origin. If it's not where it's supposed to be, well, then the real adventure begins. Either way, we'll learn something. We'll understand the universe a little better. We'll have one more piece of the puzzle. And then we'll look up at the night sky and wonder what else is out there, what other visitors might come, what other mysteries might unfold. Because that's what we do. We're humans. We wonder, we explore, we reach for the stars, literally and figuratively. And sometimes, just sometimes, the stars reach back. So sleep well tonight. Or don't. Either way, look up at the sky before you go to bed. Somewhere out there, moving too fast for your eyes to track, too dim for you to see without a telescope, is 3I/ATLS. It's real. It's out there. It came from somewhere beyond our comprehension, and it's heading somewhere we'll never know. And for just this moment, for just this brief intersection of trajectories, it's ours to wonder about. What is it? Where did it come from? Is anyone else wondering about us the way we wonder about it? We don't know. Not yet. Maybe not ever. But we're asking the questions, and that, in the end, might be the most human thing we can do. Thanks for watching, keep looking up, and remember the universe is stranger than we imagine. It might even be stranger than we can imagine.